All right, let's do some Mathity-Math. I have my pencil and eraser because sometimes we make mistakes and that's okay. The only thing we always try to remember is if we make a mistake, our job is to learn from it. With that said, let's get started. Here we go, first things first. It says simplify the following ratio where possible. Okay, so starting here for number 1, we have the ratio 6 to 7. And these do not have any numbers that they can both be divided by. So this one is actually finished. So this one is already in simplest form. So I'm just going to actually rewrite it to make sure that my teacher knows that I know. Okay? I'll just put a little, I always like to box my answers, but that's just my choice. Okay, number 2, we have the ratio of 12 to 8. So when we look at this, we can approach it from a couple different directions. We can say, hey, they're both even. Let me try the number 2. So 12 divided by 2 is 6. And 8 divided by 2 is 4. And that ratio is simpler, but it is not yet the most simplified. So I can say, you know what? They're still even. Let's do it again. 6 divided by 2 is 3, 4 divided by 2 is 2, and there we go. 3 to 2, simplified. We could have also done this one by just realizing that they both share a 4, and 12 divided by 4 is 3, and 8 divided by 4 is 2, okay? All right, number 3, we have the ratio of 24 to 18. So once again, we could look at this and say they're both even. Let's use the number 2. Or you could look and say, hey, you know what? I know that 24 can be divided by 6, and I know 18 can be divided by 6. Well, 24 divided by 6 is 4, and 18 divided by 6 is 3. And I get the ratio 4 to 3, and that is simplified. If you're not comfortable doing that, let's do it the other way. If we know they're both even, 24 divided by 2 is 12. 18 divided by 2 is 9. And then I can say, well, I also know that 12 divided by 3 is 4, and 3 divided by 3 is 3. And that would also get us there. So good job. Either way. All right, moving on. It says, write 2 equivalent ratios for each of the following ratios. Okay, oh, that actually should be an S. See, I made a mistake and I fix it, and I'll try to be more careful next time because it should say ratios. All right, so the first one, we have 1 to 3. So if we're gonna make an equivalent ratio, one thing we could do is just multiply each term by the same value. So for instance, I'll just multiply 1 by 2. 1 times 2 is 2. And I'll multiply 3 times 2. 3 times 2 is 6. And just like that, I made an equivalent ratio. I could also say 1 times 4. 1 times 4 is 4. And 3 times 4 is 12. And once again, an equivalent ratio. I've had some students who like to be kind of cheeky, and they'll just say, well, you know what? I'll just write 4 times 10 is 40. And 9 times 10 is 90, and 4 times 100 is 400, and 9 times 100 is 900, and yeah, those are also equivalent ratios. Looking at this one, we could go the other direction. We could divide by 10, and we'd have the ratio 2 to 3. That would totally work. We can do that. And we could also multiply by 2, and we could say 40 to 60. The trick is, whatever you do to one term, you just do to the other, as long as it's multiplying and dividing, and you will write an equivalent ratio. Remember though, just stick with multiplying and dividing, okay? All right, the last question on this page, it says, is the relationship shown in the graph proportional? So this is a relationship, and so we need to decide, is it proportional? So the way we know if it is proportional and if it does have a constant of proportionality is when we look at a graph, there's 2 rules we look at. The first, is it a straight line? Whoop, it is a straight line. And the second is, does that line pass through the origin? 0, 0. And this line goes right through 0, 0. So we could say yes. If you wanted, you could write yes, it is a proportional relationship. And because it has a because it is a proportional relationship, that means it has a constant of proportionality. And that constant of proportionality in an equation will be represented as the k. So this equation says y is kx. And this k value is what we multiply all of the x values by to get the y value, and it creates this straight line. So if we want to identify k, or the constant of proportionality, we just need to look at the line and try to identify what's happening here. So for instance, if I'm here and I go over 1 and I count up 1, 2, 3, and I went 3. So you can see I went over 1 and up 3. Over 1 and up 3. And I ended up there. And I watch again, I go over 1, 1, 2, 3, oh, and I went over 1 and up 3 again. But if I could keep going over 1, up 3, over 1, up 3, over 1, up 3, but let's take it back. What if instead of going 1, I went up over 2? So I went over 2. Well, let's see. I go over 2, 1, 2, 3, 4, 5, 6. And I hit right there. What if I went over 3? 1, 2, 3. And I count up. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm starting to see a pattern. And remember, guys, math is built on patterns. What if I went over 5? And I go up. Look at that. I'm at 15. Look at a nice big dot there. 15. So if you look at all of these places I went on this line, see what happens here. Well, 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. 15 divided by 5 is 3. It's constantly coming up with an answer of 3. And that's because 3 is in fact our constant of proportionality. And the way that works, just to take this one step further in the context of the Cartesian plane, what it's saying is, for instance, this point right here is on the x is 1 and the y is 3. I can write this right here. So those are my x's and my y's. And if you look at this equation, if I have y is 3, because we said k is 3, and then my x. So if I put in this x for 1, 3 times 1 is 3. If I put in this x for 2, 3 times 2 is 6. If I put in x is 3, 3 times 3 is 9. And if I put in x is 5, 3 times 5 is 15. So that's how it works. All right, let's go to the next page. Ta-da! It says here, is the relationship shown in the table proportional? If so, what is the constant of proportionality? So again, if we just think about it, if we think about this equation, I'll write it right here. Y is k times x. You can ask yourself, what do I have to multiply this x by to get that y? So this x times something will equal that y. So that's not a very good time. There we go. Okay. So 2 times what gives us 6? Well, that is 3. And if we have a constant of proportionality, this value right here will constantly or always be the same. So the next question is, 7 multiplied by what would give me 21? Well, it is in fact 3. 13 multiplied by what would give me 39? Once again, it is 3. 26 multiplied by something gives us 78. And I think it's 3. And if you're not sure, well, just do a quick test. Let's see here. 26 times 3. 6 times 3 is 18. Carry the 1. 3 times 2 is 6 plus 1. 78. It checks out. So yeah. So is the relationship shown in the table proportional? The answer is yes. And what is the constant of proportionality? Well, k is 3. There you go. These are our answers right there. Ta-da! Moving on. It says solve for the variable x. Okay, so we have a fraction or a ratio in fractional form equal to another ratio in fractional form. And this is just a great opportunity for us to cross multiply. Okay, so I take my 7 and I multiply it by x. That gives me 7x. And I take my 3 and I multiply it by 8. And that gives me 24. Next step, I'll write it right here. I really like to lay this one out. If I know that my 7x is equal to 24, I want to isolate this x or get x all alone. So right now, x is being multiplied by 7. The opposite of multiplying by 7 is dividing by 7. That's called an opposite operation. And so after I do my opposite operation, I now do my balancing of equations. So there we go. 7 divided by 7 is 1. So that pretty much goes away because I'm multiplying now by 1 times x, and 1 times x is just x. And this is 24 over 7. This answer is now an improper fraction, and if you leave it like this, I think that's okay for this. But if we want to make it a mixed number, well, we'd say, well, how many times does 7 go into 24? And that would be 3. That would give me up to 21, and I'd have 3 left over. So there you go. So either way, these are 2 wonderful answers right there. Okay? And I think, let's go to the last one. Okay. We have 2 people, Alex and Joe, right? And they took a fishing trip last weekend, okay? Alex caught 4 bluefish and 8 redfish. So right there, that is a ratio. So I'm going to write blue, and I'm going to write red. And I'll write Alex, and I'll write Joe. Okay? So if I lay out my information just to help me see what's going on, Alex caught 4 bluefish. Good job, Alex. Let's do that. Okay? And 8 redfish. Good job, Alex. And then it says Joe caught 3 bluefish, so good job, Joe. And also some redfish. Okay, so we don't know how many redfish. So when we don't know, we can use a variable. In this case, I'll just choose x, but you can choose any letter you want. Okay? And then it says, if the number of fish the boys caught is in a proportional relationship. Aha! How many redfish did Joe catch? So again, so right here we just have ratios that are going to be in a proportional relationship. And so we have these ratios in a proportional relationship. One thing we could think about, so we could look and say, well, let's see. I don't quite know an easy way to make 4 grow to 3, right? Not the easiest one. But I can look here and I can say, hey, you know what? I have twice as many red than blue. So that means that, 4 multiplied by 2. And if you explore it this way, 3 multiplied by 2, you can figure out pretty clearly that x should be 6. And in this case, that would be 6 red fish. But let's try to solve it a different way. Maybe we could also think of it like this. I could make it into a ratio represented as a fraction. Like that. And let's see, I could cross multiply. So I'd have 4x is equal to 8 times 3 is 24. Opposite operations, the opposite of multiplying by 4 is dividing by 4. And the opposite, so I'm multiplying by 4, so I divide by 4, and then I balance the equation. So divide by 4. And 24 divided by 4 is, of course, 6. And there you go. That is your practice quiz. Good job. I believe in you guys. Remember, be kind to yourself, be kind to others, be safe, and make good choices. Bye.